NASA officials reveal they have decoded transmissions from 3I Atlas.
New objects are multiplying across the solar system as 3I Atlas presses forward on its trajectory and begins closing in on Mars. What was once a faint, distant blur of motion beyond the outer solar system has transformed into one of the most dramatic celestial encounters of the decade, captivating astronomers and sparking global fascination. This interstellar object, the third of its kind ever confirmed, has already demonstrated a pattern of behaviors that mark it as both familiar and alien. Now, with its path bringing it ever closer to the red planet, the implications for planetary science, astrophysics, and humanity's perspective on interstellar visitors are immense. Before we start, smash the like and subscribe buttons for more updates. The object was first cataloged by ATLAS, the Asteroid Terrestrial Impact Last Alert System, a survey network dedicated to scanning the skies for potentially hazardous near-Earth objects. Its initial discovery sent ripples through the astronomical community, for its orbital eccentricity marked it immediately as interstellar, an outsider passing through, unbound by the gravitational well of our sun. The fact that astronomers have now detected not just one or two, but a third confirmed interstellar visitor, hints at a universe teeming with such wayfarers. It suggests that the space between stars is not barren, but instead threaded with a quiet population of wandering bodies expelled from their home systems during violent epochs of planetary formation and now drifting freely through galactic space until chance encounters bring them near other suns. The multiplication of newly detected objects around 3I Atlas as it approaches Mars has only added to the intrigue. Astronomers tracking it with ground-based telescopes and orbital observatories have noticed that the primary body is not traveling alone. Instead, faint signatures of smaller fragments and possible companions have begun to reveal themselves. Whether these are the result of outgassing, tidal stresses, or pre-existing cluster-like structures remains uncertain, but the effect is unmistakable. What was once a solitary wanderer is now a swarm. This multiplication is not only visually striking, it reshapes how scientists think about the structural integrity of such visitors and about the processes that govern their journey. The approach toward Mars could not be better timed. Humanity now maintains a fleet of robotic emissaries in orbit and on the surface of the planet, including orbiters with high-powered instruments capable of detailed imaging and spectroscopy. For the first time, an interstellar visitor is coming near a planet already occupied by our machines, creating an extraordinary opportunity to conduct close-range observations that were impossible with one I/Oumuamua and two I/Borisov, instruments designed to monitor Martian weather, mineralogy, and surface phenomena may soon be repurposed to track this transient voyager. The orbiters that sweep around Mars multiple times each day could become our most valuable interstellar research platforms, offering perspectives unavailable from Earth. As the objects multiply, questions multiply with them. What causes an interstellar visitor to shed fragments as it enters the inner solar system? Comets from our own planetary family often display this behavior when subjected to solar heating, their volatile materials venting into space in dazzling displays of tails and coming. But 3I Atlas is no ordinary comet. Its surface chemistry may be unlike anything cataloged within the solar system. The dust and gas it expels may bear the signatures of stellar nurseries light years away. Each particle drifting off into space becomes a messenger, carrying chemical stories about the birthplace of this visitor. The fragments multiplying around it are therefore not just debris, they are data, a shower of physical samples that can be analyzed remotely through their spectral fingerprints. For Mars itself, the passage of 3I Atlas nearby is a test of planetary vulnerability. Even small fragments intersecting the Martian atmosphere could produce brilliant meteors or faint traces detectable by landers. While Earth has frequently been the focus of impact hazard studies, this moment underscores that other planets too are subject to cosmic chance encounters. The red planet, already scarred by craters ancient and vast, may soon witness the fleeting signatures of dust from a worldless traveler. Scientists are eagerly calculating trajectories, estimating probabilities of atmospheric entry, and preparing sensors to catch even the briefest of flashes. The multiplication of objects near 3I Atlas also transforms our philosophical outlook. Each additional fragment is evidence that interstellar space is seeded with complexity. It is not just lonely singular bodies tumbling through the void, but perhaps entire hierarchies of clusters, swarms, and shattered remains. If planetary systems are constantly ejecting such material during their early epochs, then the Milky Way may be alive with an invisible traffic of icy messengers. The arrival of 3I Atlas near Mars provides a dramatic reminder that our solar system is not isolated. It is porous, open to interstellar exchange, a cosmic crossroads where the architecture of other systems briefly overlaps with our own. Astronomers are pushing their instruments to the limits to capture data before the moment passes. Time is of the essence, for such objects travel at staggering velocities and their windows of proximity are short. Coordinated campaigns are underway between Earth-based observatories, the James Webb Space Telescope, and Mars orbiters. The synergy of observations from multiple vantage points promises to yield a dataset unparalleled in the history of planetary astronomy. Each measurement is a line of poetry written in the language of light, encoding density, composition, and trajectory into patterns decipherable only with patience and ingenuity. The broader implications extend to the search for life. If 3I Atlas and its multiplying fragments carry complex organic molecules, then humanity may be witnessing not merely geological debris, but chemical seeds of life. The notion of panspermia, life or the building blocks of life traveling between star systems, gains new context as we contemplate these incoming materials. While no one expects living organisms to survive interstellar exile, the resilience of amino acids and other prebiotic molecules has been demonstrated. The dust of 3I Atlas, if it drifts into Martian skies, may well be tested for such molecular traces. In this way, an interstellar visitor could become the first interplanetary laboratory for probing the universality of life's ingredients. The spectacle also carries weight for future exploration. If humanity someday seeks to journey between the stars, interstellar objects like 3I Atlas will serve as stepping stones of knowledge. They are natural test cases for our ability to track, study, and potentially intercept bodies moving at galactic speeds. Missions proposed to chase future interstellar objects are already on drawing boards, fueled by the tantalizing possibilities raised by encounters like this one. A successful observation campaign at Mars may set the stage for humanity's first true interstellar rendezvous. A mission to meet one of these visitors up close and harvest samples directly. Even without spacecraft interception, the current encounter exemplifies how much can be gained from being prepared. The multiplication of fragments around 3I Atlas could have easily gone unnoticed had astronomers not been vigilant. Instead, networks of telescopes, software pipelines, and alert systems sprang into action, capturing images that revealed a growing entourage. It is a triumph not only of technology but of collaboration, as amateur and professional astronomers alike joined forces to refine orbits, model fragmentation, and forecast the path toward Mars. This global network of watchers has turned a fleeting cosmic guest into a shared story of discovery. The public response has been equally striking. Images of the interstellar visitor, even faint and grainy, have captured imaginations across the world. To witness an object born under another sun now sailing past a neighboring planet is to experience cosmic kinship. The multiplication of fragments only heightens the drama, like sparks flying from a traveler's cloak as it strides through unfamiliar lands. Social media, classrooms, and news outlets hum with speculation, each person projecting their wonder onto the approaching spectacle. The story of 3I Atlas is no longer confined to laboratories and observatories. It has entered the cultural imagination as a sign that the universe is not static but alive with encounters. As the days pass and Mars looms closer, anticipation builds. Instruments are being recalibrated, data streams prepared, software tuned to catch the faintest glimmers. The approach of 3I Atlas is not merely a scientific milestone, but a rehearsal for the age when humanity itself becomes interstellar. By watching, measuring, and learning, we take steps toward becoming more than planetary observers. We become participants in a galactic dialogue, listening to the messages carried by these wanderers, preparing one day to send our own emissaries across the stars. The multiplication of objects near 3I Atlas as it approaches Mars is a moment thick with meaning. It is a convergence of chance and preparedness, of natural processes and human curiosity. It challenges our assumptions about interstellar debris, enriches our strategies for planetary defense, fuels our search for life's origins, and inspires visions of future exploration. As this swarm of alien fragments sweeps by a world we have made our second home, we are reminded that the cosmos is vast, dynamic, and intimately connected. The universe does not wait for us, but it offers moments such as these when we may glimpse its deeper currents, fleeting but profound. The multiplication of new objects around 3I Atlas as it advances toward Mars represents more than a mere astronomical curiosity. It is a turning point that expands the boundaries of what humanity understands about interstellar wanderers. The discovery has become a springboard for deeper inquiries that cut across physics, chemistry, planetary science, and even philosophy. Each day of its approach seems to peel back another layer of mystery, compelling scientists and enthusiasts alike to widen the scope of their imagination. With Mars standing as the next great stage for this unfolding encounter, the sheer volume of questions and implications generated by the event demands exploration from multiple angles. The interstellar nature of 3I Atlas already sets it apart, but the swarm-like behavior emerging around it is what has electrified the astronomical community. Unlike the neat single-body orbits we are accustomed to in our solar system, here we witness complexity. A solitary Voyager has given way to a growing entourage. It challenges tidy definitions of what constitutes an interstellar object. Is 3I Atlas truly just one body, or is it an interstellar cluster? If these fragments accompanied it for eons before discovery, then the Milky Way may be populated by drifting archipelagos of debris rather than lone travelers. Such a possibility hints at violent histories in other star systems, where planetary collisions or stellar perturbations launched not just isolated rocks, but entire cascades of fragments into galactic exile. Mars, as the focal point of this drama, suddenly becomes more than a destination for rovers and orbiters. It becomes a stage upon which humanity may observe cosmic traffic from beyond the sun's influence. The geometry of the approach matters here. Mars sits in a position that will allow its orbiters to scan the object with angles inaccessible from Earth. These spacecraft, equipped with instruments ranging from ultraviolet spectrographs to high-resolution imagers, will be able to take advantage of parallax and perspective to triangulate details about the object's size, spin, and composition. This circumstance turns Mars into a vantage point of rare value, and it is only by chance that we have such a technological presence there at this moment. The physics of fragmentation becomes a central subject of debate. On Earth, comets crack apart when subjected to the pull of Jupiter or the heat of the Sun, but with 3I Atlas, we must consider unknown stresses. Its material makeup may contain exotic ices that sublimate at temperatures lower than those seen in local comets, producing jets invisible to the naked eye yet powerful enough to fracture its surface. Its passage through interstellar space may have subjected it to cosmic rays and micrometeorite impacts that weakened its integrity long before it encountered the inner solar system. Each fragment seen breaking away tells us something about the conditions of its formation and journey. By studying their trajectories relative to the main body, astronomers can deduce both internal structure and external forces at play. The multiplication of objects also raises the issue of detection. The smaller fragments of 3I Atlas are difficult to track, sometimes appearing only as faint streaks of light against the background stars. This forces astronomers to push the limits of their observational techniques, stacking exposures and refining software to tease signals from noise. The ability to track such tiny, fast-moving bodies is not just a triumph of persistence, but also a rehearsal for the future. If humanity hopes to defend Earth, or Mars, from potential impacts, then learning to monitor and characterize these faint fragments is essential. In this sense, the arrival of 3I Atlas is not just serendipity, but a training exercise orchestrated by the cosmos itself. Mars may also become a laboratory for atmospheric interaction. Should dust or smaller pieces of 3I Atlas brush against the thin Martian atmosphere, they could produce faint meteors detectable by orbiters or even surface cameras. Instruments on rovers like Perseverance and Curiosity, designed primarily for geology, might be redirected temporarily to skyward glances, hunting for streaks of light. The detection of even a single meteor trail sourced to an interstellar object would be groundbreaking. It would represent the first time in human history that fragments from another star system visibly interacted with the environment of a neighboring planet. The chemistry of 3I Atlas is another area brimming with promise. Interstellar objects carry the potential to rewrite our understanding of chemical diversity beyond the solar system. Spectroscopic studies may reveal unusual ratios of elements or isotopes, pointing to origins in stellar nurseries with conditions very different from those that birthed the Sun. If, for example, the fragments show evidence of frozen carbon monoxide or ammonia in unusual abundances, it would suggest formation in an environment colder or denser than the solar nebula. This would give astronomers a rare chance to sample galactic diversity without leaving the solar system. Beyond the chemical clues lies the tantalizing possibility of complex organics. Molecules like polycyclic aromatic hydrocarbons, formaldehyde, and methanol have been detected in interstellar space by radio telescopes. If these compounds are now found in the dust of 3I Atlas, then it reinforces the idea that star systems share not just raw elements, but also the molecular foundations that can, under the right conditions, lead to life. Mars orbiters and telescopes could potentially detect absorption lines corresponding to these organics, and if fragments enter the atmosphere, detectors on the ground may register spectral fingerprints as the molecules burn up. In this way, 3I Atlas becomes more than a rock. It becomes a courier of chemistry, carrying across light years the hints of universality. The multiplying fragments also carry significance for orbital dynamics. Each piece, however small, follows a subtly different trajectory, fanning out into a family of paths. By tracking these diverging trails, scientists can refine their models of gravitational interaction within the solar system. The fragments act like tracers in a fluid, revealing the currents of gravitational fields from Mars, Earth, and even the Sun. This phenomenon transforms the event into a live experiment in celestial mechanics. Just as physicists track particles in accelerators to understand forces, astronomers now watch these natural particles to deepen their understanding of planetary perturbations. This interstellar encounter also resonates with the long-standing question of whether humans will one day interact directly with such visitors. Concepts for missions designed to intercept interstellar objects have gained traction in recent years. Projects envision fast-response spacecraft capable of launching within months of a discovery, equipped to rendezvous with and sample a passing object. The proximity of 3I Atlas to Mars underscores how advantageous it is to already have infrastructure in place. While Earth remains the hub of humanity's scientific power, Mars, with its orbiters and landers, is proving to be an unexpected outpost for interstellar observation. The lesson is clear. The more presence we maintain throughout the solar system, the better equipped we will be to seize these rare opportunities. The event also plays deeply into humanity's imagination. For millennia, Mars has been the focus of myth, speculation, and exploration. Now, as 3I Atlas approaches it, the planet becomes part of a narrative that stretches far beyond the solar system. It is no longer just the red planet of human ambition, but a waypoint in a galactic drama. This layering of meaning, where Mars is both target of colonization and stage for interstellar visitation, enriches its symbolic role. It reminds humanity that exploration is not linear but interconnected. Each advance builds bridges between planetary science and cosmic context. On the technical side, astronomers are experimenting with novel techniques to study the fragments. Polarimetry, which measures the polarization of light, can reveal details about the texture and composition of dust. Radar observations, though difficult at such distances, may yield echoes from larger fragments, allowing scientists to infer shape and rotation. Computational modeling, fed by these observations, attempts to recreate the fragmentation process virtually, testing hypotheses about internal stresses and outgassing. These simulations are not academic exercises. They sharpen predictive tools that will be vital when humanity eventually mounts dedicated missions. The significance of the multiplication of objects cannot be overstated. It suggests that interstellar bodies are not mere outliers, but potentially diverse and dynamic. If the galaxy is populated by swarms rather than loners, then the traffic of interstellar debris through the solar system may be heavier than once believed. This raises practical considerations. Planetary defense must expand its scope from Earth-centric threats to encompass interstellar intruders. Navigation of spacecraft must consider not just solar system debris, but also the possibility of encountering fragments with unusual velocities. Exploration strategies must integrate the chance of unplanned interstellar encounters. On a cultural level, the story of 3I Atlas is already taking root. It is being shared in classrooms, discussed in lecture halls, and dramatized in media. The multiplication of fragments serves as a metaphor for multiplication of ideas and perspectives. Just as one object has become many, so too has one discovery become a branching narrative, inspiring new theories, artistic works, and conversations about humanity's place in the galaxy. These cultural ripples may be as significant as the scientific ones, for they ensure that the encounter is not forgotten, but woven into humanity's shared heritage of cosmic wonder. Mars itself may gain unexpected benefits. As orbiters focus on 3I Atlas, they may also refine their own instrumentation, enhancing calibration and sensitivity. Lessons learned from tracking faint interstellar fragments can be applied to monitoring Martian dust storms, atmospheric dynamics, and even the thin traces of water vapor. The interstellar visitor thus indirectly strengthens our capabilities for planetary science closer to home. This interplay between the exotic and the local illustrates how science advances. By stretching toward the extraordinary, we sharpen our tools for the ordinary. The future implications are immense. If humanity succeeds in studying 3I Atlas and its multiplying fragments in unprecedented detail, it may catalyze the next generation of missions. Already, proposals circulate for spacecraft that could linger in interplanetary space, waiting like sentinels for the next interstellar visitor. Others suggest embedding instruments on Mars specifically for such events, recognizing that the planet may again serve as a natural observatory. These visions underscore a truth. The galaxy will not send invitations, but it will send guests, and it is up to humanity to be ready to greet them. The approach of 3I Atlas is more than a passing spectacle. It is a lesson in preparedness, a gift of scientific opportunity, and a reminder of the interconnectedness of worlds. Each fragment multiplying around it is both a challenge and a revelation, expanding humanity's horizons not only outward into space, but inward into our own capacity for curiosity and wonder. Mars, for now, is the place where these trajectories intersect, but the reverberations extend far beyond. The universe, alive with motion and encounter, has once again reminded us that discovery is not scheduled but sudden, not predictable but profound. And so the moment builds, fragment by fragment, orbit by orbit, until the red planet and the interstellar swarm share the same patch of sky. For those watching from Earth and from robotic eyes circling Mars, the encounter will be a window into the deep currents of the galaxy. For the human story, it is a chapter that expands the narrative from planetary exploration to cosmic participation. 3I Atlas, multiplying as it goes, carries not just the material of another system, but the promise of connection, of a universe that does not isolate but converges, bringing the faraway into fleeting but unforgettable reach. The journey of 3I Atlas toward Mars continues to unfurl layers of significance that extend far beyond the boundaries of typical planetary science. With every observation, new perspectives emerge, and the sense of encountering something wholly other only deepens. The multiplication of fragments and the approach to Mars form a dual narrative, one about the object itself, and the other about the infrastructure, imagination, and capacity of humanity to respond to rare cosmic events. As more telescopes are turned toward the visitor, and as the data begins to accumulate, the field of interstellar science expands in directions that no one could have fully anticipated when the first faint detection was made. One of the most compelling aspects of this unfolding episode lies in the realm of orbital prediction. Tracking an interstellar object with multiple fragments tests the limits of celestial mechanics. Each particle shed from the parent body develops a slightly different trajectory, shaped not only by the sun's gravity, but also by subtle outgassing jets, radiation pressure, and the gravitational pull of Mars as the swarm draws near. The challenge is akin to following the threads of a tangled skein, each twisting under invisible forces. Yet this very complexity provides a laboratory for refining predictive algorithms. By comparing predictions to real-time observations, astronomers can test the accuracy of their models, improving them not only for this visitor, but for all small-body dynamics within the solar system. This refinement is critical in an era when planetary defense and asteroid mining are becoming increasingly urgent considerations. The orbital evolution of these fragments also hints at potential longer-term consequences. While the main body of 3I Atlas will pass through the solar system and depart into interstellar space again, Some of its shed material could remain gravitationally bound, at least temporarily. Dust grains slowed by solar radiation pressure might spiral inward, mingling with the background zodiacal cloud. Larger fragments, if captured even briefly by the sun's influence, could linger for decades or centuries, becoming interlopers indistinguishable from native comets until their unusual velocities reveal their origins. In this sense, 3I Atlas may leave behind a legacy, small but real, of interstellar material that remains within our solar system long after the parent body has gone. From a planetary science perspective, the Martian environment offers a remarkable advantage for studying these effects. The thin atmosphere and clear skies make Mars an excellent observational platform for high-altitude meteors. Even without human observers, the possibility exists that orbiters equipped with sensitive detectors could capture trails of light as fragments enter the Martian sky. These trails would provide data about particle density, speed, and composition. The opportunity to measure the physical properties of interstellar fragments as they ablate in a planetary atmosphere is unprecedented. Such data could refine our understanding of how volatile materials behave under sudden heating, offering insights not only into exoplanetary chemistry but also into the resilience of molecules traveling across interstellar distances. The physics of resilience is itself a fascinating dimension of the 3I Atlas event. For an object to survive the journey from one star system to another requires extraordinary endurance. Between the stars, the radiation environment is harsh. High-energy cosmic rays bombard interstellar wanderers relentlessly, altering molecular bonds, breaking crystalline structures, and leaving behind a patina of altered chemistry. Micrometeorite impacts over millions or billions of years scar their surfaces. Yet despite this barrage, 3I Atlas persists as a coherent body, and its fragments still carry intact information about its interior. The endurance of such objects raises questions about how common they are and how much material is exchanged between systems over galactic timescales. If objects like 3I Atlas can endure, then the galaxy is far more interconnected than previously imagined, its stars quietly sharing material across light years. The very act of sharing material transforms the way we think about the boundaries of star systems. Instead of imagining solar systems as isolated islands, the 3I Atlas event encourages us to see them as porous ecosystems. During the chaotic early epochs of planetary formation, countless bodies are ejected outward, sent drifting across interstellar space. These exiles carry with them the chemical signatures of their birthplaces. Some, like 3I Atlas, find themselves wandering near alien suns, where they may be studied by other civilizations, much as we are studying this one. The multiplication of fragments around the current visitor suggests that many interstellar objects may not survive intact, but instead distribute their material more widely, scattering information across cosmic distances. In this way, the galaxy may be thought of as a grand archive, its pages written in dust, ice, and rock. Mars's role in this unfolding chapter underscores the serendipity of human exploration. When rovers and orbiters were dispatched to study the red planet, the goal was to learn about Martian geology, atmosphere, and potential habitability. No one anticipated that they would one day serve as interstellar observatories. Yet that is precisely what is happening. Instruments designed to measure atmospheric gases may detect traces of interstellar volatiles. Cameras meant to map the Martian surface could capture the brief streaks of meteors from alien fragments. This repurposing of technology is a hallmark of scientific progress. Tools built for one purpose often reveal their greatest value in unexpected contexts. The event also highlights the necessity of adaptability in scientific missions. Spacecraft operate on tight schedules with carefully planned sequences of observations. The sudden arrival of 3I Atlas forces teams to rethink priorities, to recalibrate instruments, and to seize fleeting opportunities. This requires coordination across agencies, nations, and disciplines. Astronomers, planetary scientists, engineers, and data analysts must all work in concert, guided by the knowledge that the window for observation will not remain open for long. In this sense, the multiplication of fragments around 3I Atlas is mirrored by the multiplication of efforts on Earth and around Mars, an expanding web of collaboration sparked by a passing visitor. Cultural imagination, too, expands in response to such an encounter. For centuries, Mars has served as a mirror for human hopes and fears. Now, as an interstellar object approaches it, the red planet becomes a crossroads of cosmic narratives. In literature, art, and philosophy, this convergence will resonate. Writers may imagine the fragments as messengers from distant civilizations. Artists may paint Mars beneath a sky streaked with alien meteors. Philosophers may ponder what it means for humanity's neighboring world to be touched by material from another star. In every case, the encounter becomes more than a scientific event. It becomes a cultural touchstone, a moment when humanity glimpses its deeper connection to the cosmos. The technological spin-offs of such an encounter are also significant. Tracking faint, fast-moving objects pushes observational technology to its limits. Advances in sensor sensitivity, data processing, and predictive modeling developed during the study of 3I Atlas may later be applied to Earth observation, climate science, and even defense systems. Space science often generates innovations that ripple outward into other fields, and the effort to study this interstellar visitor will likely be no exception. The multiplication of fragments forces astronomers to detect signals far weaker than those usually pursued, sharpening tools that may later be used to track space debris, monitor satellites, or study faint atmospheric phenomena. The educational impact should not be underestimated either. Events like the approach of 3I Atlas inspire the next generation of scientists and engineers. Classrooms around the world will follow the story, and students will learn not just about astronomy, but about collaboration, persistence, and curiosity. They will see how a fleeting discovery can mobilize an entire global network of observers. For young people who dream of careers in science, 3I Atlas serves as a vivid reminder that discovery is not confined to textbooks, but is happening now, with mysteries still waiting to be solved. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on new objects multiplying as 3I Atlas nears Mars? We want to hear from you. Thank you for watching, and see you next time.